Assalamu alaikum students. So today we'll be solving additional mathematics paper 1, which is the non-calculator based paper. I'll tell you the good tips and tricks to help you solve this paper quickly. So kindly pay close attention to all the details that we'll be discussing while solving this paper. So the first question says that the curve y is equals to 2x squared plus k plus 4 intersects the line y is equals to k plus 4x at two distinct points. Find the possible values of k. So if I know that if I wanted to find their point of intersection, I would have had to simultaneously solve both the equations. And as both are in terms of y, I can simply equate one with the other. So I can say that 2x squared plus k plus 4 is k plus 4 times x, and 2x squared minus k plus 4x plus k plus 4 is 0. If I would have solved this equation, which right now I can't, I would have got the point of intersection. Now I already know that there are 2 points of intersection for the line in the curve. So that means that the discriminant of this equation will be greater than 0. The discriminant will be greater than 0. Discriminant is b square minus 4ac. B in this case, which is the coefficient of x, is minus k plus 4 whole squared minus 4a is 2 and c is again k plus 4. So if I intend to solve this one, I'll get k square plus 8k plus 16 minus 8k minus 16 is greater than 0. 4 2s are 8, 8 4s are 32. Sorry, this has to be minus 32 is greater than 0. So 8k and 8k cancelled out. 8k square minus 16 is greater than 0. Now it is a quadratic inequality. You must follow all the basic steps of solving a quadratic inequality, which are first sketching the shape. This will be a happy face. The critical points will be 4 and negative 4. And we are looking for the values when this is greater than 0. That means it is above the x-axis. So this region or this region. If you're confused about quadratic inequalities, feel free to go to my other video in which I've explained it in detail. K square, k will be less than negative 4 and k will be greater than 4. So this is how we can do this first question. Moving on to question number 2, which is regarding a cubic function or a cubic curve to be specific. The diagram shows the graph of y equals to fx, where fx is a cubic polynomial. Find fx, giving your answer as a product of linear factors. Now using the roots, what are the 3 roots? The 3 roots are x is negative 5, x is negative 1, and x is positive 2. So what will be the 3 factors? X plus 5, x plus 1, and x minus 2. And the function will be fx is k times the entire thing. Now, in order to find k, you can plug in the y-intercept, y as 5 and x as 0. 0 plus 5, 0 plus 1, 0 minus 2. So the value of k is negative half. So fx is negative half, x plus 5, x plus 1, and x minus 2. So this is the final function that we will end up with. Now the question wants us to write down the value of x such that fx is less than 0. It is negative. The curve is negative below the x-axis. And where do we find it as negative? If we trace the region where we find it as negative, it is this region where it is negative, and it is this region. So what are the values of x in this region? X can either be between negative 5 and negative 1, or x is greater than 2. So these are the solutions to the first two questions. Moving on to question 3. Then moving on to question number 3, which is regarding mod inequalities. I'll tell you a very interesting way of attempting this one. First and foremost, in order to remove mod, we square both sides. And once we do that, we do not need to write the mod sign, because by squaring, all negative values also become positive. So this is how we can remove mod. Now, instead of expanding and simplifying it, there is a trick that we can use. 5x plus 4 whole squared, 2x minus 3 whole squared is less than equal to 0. Now, if we have the difference of square, a square minus b square, I can always write it as a minus b and a plus b. If you observe closely, you have a square on both these brackets. So what can you do? 5x plus 4, which is a, minus b, 2x minus 3 is the entire b, and a plus b is less than equal to 0. So now 5x minus 2x is 3x plus 7. I hope I'm writing it correctly. And 5x plus 2x is 7x plus 1 is less than equal to 0. Now again, another quadratic inequality. The shape that it must have is a happy face because the coefficient of x square is positive. Now what are the critical values? The values when you will find it equal to 0. Remember, this is just a part of the solution where we find critical values. 7x plus 1 is equals to 0. So the value of x is negative 7 upon 3 or negative 1 upon 7. Now this is negative 7 upon 3 and this is negative 1 upon 7. And I'm searching for the region when it is less than equal to 0, which means this region below the x-axis. So it will be in between negative 7 over 3 and negative 1 over 7. Moving on to question number 4, another function related question. The function f is defined as a quadratic function x squared plus 2x minus 3, and the domain is x is greater than or equal to negative 1. Given that the minimum value, they've already provided us with the minimum value. Okay, we could have just figured it out ourselves as well. Okay, so they have given it to us. If we wanted to do it, we could have done this ourselves as well, because when x is negative 1, explain why fx is an inverse. So if we are considering the negative value, negative 1, and we know that the domain is greater than or equal to negative 1, before making the function, just write the curve. The turning point is at x is negative 1. I currently do not know the y coordinate and I'm letting it be as it is. Now the domain is x is greater than equal to negative 1. That means x is negative 1 here, and on the right x increases. So this is the part of function that we are talking about. And in the given domain, I will say that in the given domain, f is a 1 to 1 function. So the domain that has been provided to us, in that domain, f is a 1-to-1 function, and hence it will have an inverse. And now the question wants us to draw the graph of or to sketch the graph of these functions of the function and its inverse. So I already have the quadratic function. I'll just be simplifying it. Fx is x square plus 2x minus 3. I can just do the completing square x square, or I can find out the y coordinate and then do the completing square. It's the same thing, minus 1 squared minus 3. Completing square is very important. X plus 1 whole squared minus 4. So the turning point of this one will be, or the vertex or the turning point is -1 comma -4. Okay, and what other things do I need? The coordinate axis. Okay, the y-intercept is when x is 0. So f of 0 is -3. That means it will be cutting at 0 comma -3. This is the y-intercept, and for the x-intercept, y is 0. X plus 1 whole squared minus 4. 4 is x plus 1 whole squared. X plus 1 is, I'll just write it over here rather than taking another page. I'll say x plus 1 is 2, or x plus 1 is -2. X is 1 or x is -3. These are the two possible x-intercepts, but for the given domain, we know x has to be greater than 1, -1. So this solution is not possible. This is what we'll not be plotting. So we have the intercepts and we have the turning point. Keeping that in mind, I'm just making a rough sketch. This is -1, -2, -1, -2, -3, -4. It is supposed to be a happy face. Just made it a little more steep than it should be. Okay, now this is -4 and it is cutting over here at -3, and it is cutting over here at 1. Now the function and its inverse are the reflection of each other on the line y is equals to x. Now I can sketch a line of y is equals to x, and once I reflect on it, this is my fx. This is my original function fx, and the inverse will just be a reflection of this one. That means that if this was cutting at 0, -3, it will go to -3 and 0. And if this was cutting at 0, 1, it will become 1 and 0. So something like this. They'll be crossing each other on this line. So this is a graph of the inverse of the function f. Moving on to the next question. So question number 5, show that sin x tan x upon 1 minus cos x is 1 plus sec x. Now, starting with the left hand side, not necessarily, it's not a rule, but it appears so. Not for left hand side, because it's not an inequality. I just have to write this as 1 plus sec x. So I'll be writing it as sin x. I can convert everything into sine and cos, and I can write my target as a rough target is 1 plus 1 upon cos x. So this is what I need to end up with, 1 plus 1 upon cos x. So in place of tan x, I will write sin x upon cos x, and I'll be writing it as divided by 1 minus cos x. Now this can be written as sin square x upon cos x and times 1 upon 1 minus cos x. Now the sine square x can be written as, because I need everything in cos eventually, 1 minus cos square x. And this is 1 over 1 minus cos x. So now 1 minus cos square x, again difference of square, I can write it as 1 minus cos x, 1 plus cos x, and cos x over here as it is, and 1 over 1 minus cos x. Now 1 minus cos x and 1 minus cos x cancelled out, and I am left with 1 plus cos x upon cos x. I can write these denominators separately, 1 over cos x plus cos x over cos x. So cos x over cos x is 1, 1 over 1 plus cos x. I've rearranged it, and the answer is 1 plus sec x. So this is what we'll end up with once we solve this equation. Moving on, we now need to differentiate this entire thing. Sin x tan x upon 1 minus cos x can be written as the derivative of this entire thing as tan x and sec x. Okay. So if I have wanted to differentiate this, I will basically have to differentiate 1 over 1. Now what if I write 1 upon cos x as cos x to the power negative 1? So the derivative of 1 is 0. The derivative of cos x will be negative 1. Cos x to the power negative 2, and the derivative of cos x, which is minus sin x. So this will be sin x and cos square x. Or this will become cos नीचे जाएगा, cos to the power, and I can write it as sin x upon cos x into 1 upon cos x, so which is tan x sec x. So this is how we can write the derivative of given function. Moving on to question number 6, solve the following simultaneous equations. So first we can simplify this. Log 3x plus y is 2, so x plus y is 3 squared, which means x plus y is 9. This is one equation. I can simplify it further as per my requirement, and the other one is log 3x plus 1 squared is log 3 y plus 2. So basically, x plus 1 whole squared is y plus 2. Okay, so now I can just make any of these the subject of the formula. I can say that x is or y is 9 minus x. I can plug it in the next equation. X plus 1 whole squared is 9 minus x plus 2. So x squared plus 2x plus 1 is 7 minus x. X squared plus 3x plus 8 is 0. 7 इधर आके minus 6 हो जाएगा. Minus 6 is 0. ओके -6 इज 2 3s आर भी नहीं देगा मुझे, 6 1s आर भी नहीं देगा. ओके, I might have made a mistake in the previous. हाँ, 9 plus 2 is supposed to be 11, sorry. So when 11 will come over here, it will become -10. Now, x squared plus 5x minus 2x minus 10 is 0. You can also use the quadratic formula, but do not make an error. X common, x plus 5 minus 2 common, x plus 5 is 0. So x plus 5 and x minus 2 is 0. So x is either -5 or x is +2. And now for y, if I use x as -5, remember x is an input of log. So if I put a -5 over, the input of log will become negative. So this value has to be discarded. This value will have to be discarded. The only value of x we'll consider is +2. If I plug in a +2 over here, 9 minus 2 is 7. So x is 2 and y is 7. This is a solution to the logarithmic equation that the question provided us with. Moving on to question number 7, which is regarding the linear law. When y cube is plotted against ln x, a straight line graph is obtained. So if I'm using y is mx plus c, y being the coordinate or the variable on the vertical axis, x being the function or the variable on the horizontal axis. So y cube is m, I do not know, and on the horizontal I have ln x plus c. How can I find the gradient? I can use these 2 points that the question is provided. Gradient is 15 minus 5 upon 1 minus 6. Sorry, 6 minus 1 over 5 written 15 minus 5, 6 minus 1. 15 minus 5 is 10, 10 upon 5 is 2. So the equation becomes y cube is 2 ln x plus c. Now in order to find the y-intercept, I can just simply plug in. I'm writing this equation in this way as well. Y as 5 and x as 1. So the value, remember this x is not the variable x, it is the coordinate on the horizontal axis. So I cannot just plug in x and y over here, that would be wrong. I would have to plug it in place of entire y cube and entire ln x. So the value of c is 3. And now I can just write the equation y cube is 2 ln x plus 3. Y cube is now ln, simply चलो इसको ऐसे भी छोड़ सकते हैं, और I can write it as y in terms of x कह रहा है, तो just to be sure I can leave it उस तरह भी. Y is ln of x square plus 3 to the power 1 upon 3. So this is how I can write y in terms of x. Now the question wants us so it is a positive gradient value, a positive gradient line, and the question wants us to write corresponding values of x. Okay, so we know that when it is a positive gradient line, if I'll increase the input of ln, my overall value of y will increase. So y has to be greater than equal to, sorry, greater than -1. So if I write the value of greater than -1, I'll say that ln of x squared plus 3 to the power 1 over 3 will be greater than -1. I can cube both sides. Ln x square plus 3 is greater than cube of -1 is -1. Ln of x square is greater than -4. X square is greater than e to the power negative 4 and x is greater than, if I take square root on both sides, e to the power negative 2. These are the corresponding value of x. X has to be greater than negative 2.
Okay, so continuing with question number 8. The polynomial px is 6x cube plus ax square plus bx plus 2, where a and b are integers, has a factor x minus 2. Given that p of 1 is equals to negative p2 times p of 0, find the value of a and b. So if I were to find p of 1, that means wherever I have x, I'll be plugging in 1 plus a into 1 square plus b into 1 plus 2. So p of 1 will take the value 6 plus a plus b plus 2. So the value of p of 1 is a plus b plus 8. Similarly, p of 0, wherever I have x, that will be 0. I'll be left with 2. So the question says p of 1 is minus 2 times p of 0, which means p of 1 is a plus b plus 8 is equals to minus 2 times p of 0 is 2. So a plus b is equals to minus 4 minus 8 is minus 12. So this is one equation, but I have two unknowns. Now if x minus 2 is a factor, when I put x minus 2 as 0, the value of x is 2. That means p of 2 must be equal to 0. So wherever I have x, I'll be plugging in 2 over there. A 2 squared plus b into 2 plus 2. So p of 2 is 6 into 8 plus a into 4 plus 2b plus 2. And this should be equal to 0. 48 plus 2, 4a plus 2b plus 50 is equals to 0. I can simply make a the subject of formula in this one. A is minus 12 minus b, and I can plug it in the first one. 4 times minus 12 minus b plus 2b plus 50 is 0. So minus 48 minus 4b plus 2b plus 50 is 0. So minus 2b is minus 2, and the value of b is negative 1. Now all I need to do is find the value of minus 2b is minus 2, so b is 1, sorry. And the value of a is minus 12 minus b, so the value of a is negative 13. So these are the values of a and b that we will end up with. Moving on to part B, using our values of a and b, find the remainder when p of x is divided by 2x minus 1. So a is negative 13 and b is 1. So let me write the polynomial first. 6x cube minus 13x squared plus x plus 2. This is the polynomial I get when I plug in the values of a and b. So I need to find the remainder when it is divided by 2x minus 1. So if I make 2x minus 1 0, the value of x is half. By plugging in the value of x as half, I'll get my remainder. Using the remainder theorem, cube minus 13 into half squared plus half and plus 2. So p of half, it will be my remainder, 6 upon 8 minus 13 upon 4 plus half and then plus 2. Let me simplify because this is a non-calculator paper. So 3 upon 4 minus 13 upon 4 plus 1 upon 2 plus 2. So 3 upon 4 minus 13 upon 4 should give me 10 upon 4 plus half plus 2. Minus 10 upon 4, sorry. which simplifies to minus 10 upon 4 if I cancel it with 2. 5 upon 2 minus 5 upon 2 plus 1 upon 2 plus 2. So I can simplify and my remainder will be minus 5 upon 2 plus 1 upon 2 is minus 4 upon 2. Minus 4 upon 2 is minus 2 and plus 2. And the remainder that I end up with is 0. So this shows another thing that when the remainder is 0, 2x minus 1 must be a factor of the cubic expression. And now in the last part, the question wants us to factorize this. Now we know two factors of this cubic expression. One of them was x minus 2. The other is 2x minus 1. And we know two linear factors. So the third one will also be a linear factor. I'll be comparing coefficients for this one. You can also use long division. 6x cubed minus 13x squared plus x plus 2 minus 13x squared plus x plus 2. One of the factors was x minus 2. The other is 2x minus 1. And the third is a linear one for which I'll be writing. I shouldn't write bx plus q. I'll just write ax plus b. Because the linear factor can have a maximum two terms, x minus 2, 2x minus 1, and ax plus b. Now comparing coefficients, I'm not even expanding the right side, but if I wanted to, I'll be focused on just two terms. One is the cubic one, and the other will be a constant. So with enough practice, you can get there. Okay. So if I compare x cube, on the left, the coefficient of x cube is 6. On the right, I'll get x cube when x multiplies by 2x and then they multiply by ax. So the coefficient of x cube will be 2a. So the value of a is 3. Now if I compare the coefficient of the term that is independent of x, on the left it's 2. On the right, I'll get minus 2 multiplied by minus 1 multiplied by b. That will give me 2b. So the value of b is 1. So if I factorize it completely, my polynomial will be x minus 2, 2x minus 1, and 3x plus 1. And this is how I'll factorize the cubic polynomial for which I have already figured out the two factors. Okay, so moving on to question number 9. Find an equation of the tangent to the curve this at the point where x is 1. In order to find the equation of a straight line, we need two things. We need the gradient and one complete point on the line. They haven't provided us with the gradient and neither have they provided us with a complete point on the line. They have only given us the x coordinate. So can we find the y coordinate by plugging it in the equation? 1 cube minus 6 into 1 squared plus 3 into 1 plus 10. So the y coordinate will be 1 minus 6 plus 3 plus 10. 14 minus 6 is 8. So the point that I'll be using is 1 comma 8. Now for the gradient, I know it's a tangent to the curve, so I can simply differentiate the equation of the curve. I'll get 3x squared minus 12x plus 3. And gradient of tangent can be obtained by plugging in the value of x. 3 into 1 squared minus 12 into 1 plus 3. 3 plus 3, 6. The gradient is negative 6. So y minus y1 is equals to m bracket m is the gradient negative 6 x minus x1. So y minus 8 is, x1 is 1 minus 6x plus 6. Y is equals to minus 6x plus 14 because they have asked us to give it in the form of y is equals to mx plus c. So this is the equation that we will end up with for the tangent. And now the question is asking us the coordinates of the point where this tangent meets the curve again. So this is the equation of the tangent, and I already have the equation of the curve. I already know a point when it meets the tangent y, which is 1 comma 8. So I can find the points of intersection by simultaneously solving the two equations. One is the equation of the curve, both are equals to y, so I'll just be equating them. And the other is minus 6x plus 14. So if I simplify this, x cube minus 6x squared plus 9x minus 4 is 0. Now this is a cubic expression that we first need to factorize and then we'll solve it. We know one of the factors, which is one of the root, which is 1. If 1 is a root, ek jagah where it cuts the curve is 1. So if I try to factorize this cubic expression, I already know a factor which is x minus 1, and the other is a quadratic factor that I do not know. So I can either do comparing coefficients or I can do long division with this cubic expression and figure out my values of a, b, and c. Right now, for the ease of it, I'll be doing comparing the coefficients. X cubed minus 6x squared plus 9x minus 4 is equivalent to ax cubed plus bx squared. Okay, ax cubed minus, I'll write it this way, ax squared plus bx squared minus bx plus cx minus c. So now if I compare the coefficients, find my values of a, b, and c. First, if I compare the coefficient of x cube, on the left it's 1, on the right it's a, so I figured out my value of a. Then if I compare the constant or the term independent of x, on the left it's negative 4, on the right it is negative c, so the value of c is 4. And then I can compare any of the terms. I am using x squared. On the left side it's negative 6, on the right it's minus a plus b. I already know the value of a, minus 1 plus b. So the value of b is negative 5. So now I have factorized cubic expression. And if I write the same cubic expression in the factorized way, the value of a was 1, so x squared minus 5x plus 4 is equals to 0. Now I can simply try to break the middle term. X squared minus 4x minus x plus 4 is 0. X minus 1, x into x minus 4 minus 1 into x minus 4. X minus 1, x minus 1, x minus 4 is 0. X minus 1 whole squared, x minus 4 is 0. Okay, even in the class when I solved it yesterday, students who were present, I told them the best way to do this question is not this one. I've used this one because students get confused. But once I know that when 1 is a tangent, it has to be a repeated root. X minus 1 will be a repeated root.
So once you know that it is a tangent, you can say that it is a repeating root, and we have come to that conclusion eventually. So if you knew that it is a repeating root, what you should have done was, even while doing comparing coefficients for this one, once you knew that x minus 1 is a repeating root, why? Because it is tangent to the curve. We do that even while figuring out the equation of a cubic curve. So x minus 1 must have been squared and the other one will be a linear one, ax plus b. This should have made things very easy for us and we would have got our other linear factor easily. Eventually we'll get to the x coordinate, which is 4 either ways, and the y coordinate can be obtained by plugging in the value of 4 in any of the equations, whether it's the curve or the tangent. So the value of y is minus 24 plus 14. So the coordinate is 4 comma minus 10. So this is where the curve meets the tangent again. Moving on to question number 10. This is a definite integral question. And the question wants us to find the exact value of this integral. So if I wanted to integrate this, I will have to make some changes. Only then will I be able to integrate it. The upper limit is 4. The lower limit is 2. I'll just expand the numerator first. X squared plus 2x plus 1 upon x squared. In integration, we do not study any product or quotient rule, so we can only integrate when terms are being added with each other. We cannot add when another function is being divided by the entire thing. So we'll have to simplify it in a way that we are only left with functions that are either adding or subtracting with each other. So what can I do is I can write them as separate denominators, x squared upon x squared plus 2x upon x squared plus 1 upon x squared. Now let's simplify. What do we end up with? 1 plus 2 upon x plus 1 upon x squared. And now these three are being added up and we need to find their exact value and must integrate them. We know if we have a linear function in the denominator, for example, we have x. If I take it up and I write it as x to the power negative 1, when I want to integrate it, it will make x as the power 0, and when dividing by 0, that will make it undefined. So this won't be integrated in the conventional way. We'll integrate it using ln. I'll just write all three of them separately so that it is very much clear to us. Okay, 1 will be integrated with ease. I'll eventually apply the limits. This is just to help you people understand you're not supposed to break everything down separately. And okay, so these are the three things that I need to integrate. Now I'll make some changes here as well. This x square will go up. It will become x to the power negative 2. This 2 can just be taken out. I'll just be left with 1. So if I have x in the denominator and the derivative of that is in the numerator, this will be integrated as ln x. Now I'll be putting all of them together because they have the same limits. The integral of 1 is x plus 2 integral of 1 over x is ln x. And the integral of this is x will get the power negative 1 divided by the increased power, which is negative 1, the upper limit being 4 and the lower limit being 2. Now we are supposed to find the exact value. So I'll just simplify it a tidy bit more. X plus 2 ln x minus 1 upon x, and the upper limit is 4 and the lower limit is 2. So now when I plug in the values, what do I get? 4 plus 2 ln 4 minus 1 upon 4 minus 2 plus 2 ln 2 minus 1 upon 2. So if I simplify this, 4 plus ln 16, how did I get that? 4 squared minus 1 over 4 minus 2 minus ln 4. I have written this 2 as a power of 2, which will make it square. And then I have just multiplied with a negative value and then plus 1 upon 2. So 4 minus 2 is 2, and minus 1 over 4 plus 1 over 2. Okay, for the time being, I'll just write it as it is so that you can understand. And the logs are being subtracted, so their inputs can be divided 16 upon 4. So I'll just take 4 as the LCM. 4 twos are 8 minus 1 plus 2 plus ln of 4. So 8 plus 2, 10 minus 1, 9 upon 4 plus ln 4 is what we should end up with. This is the exact value. You cannot simplify it further. This is what you should end up with. I hope this is clear up till now. We have done 10 questions. I hope your spirits are high and you are able to do more questions now. You must be getting confident, your confidence back. Okay, now we have a vector question. Question number 11 is regarding vectors. OP is 2B, OS is 3A, SR is B, and PQ is A. OR and QR intersect at point X. So we need to write OQ in terms of A and B. So if I want to go from O to Q, I can simply go O to P, which is 2B plus P to Q. OQ is, you must put an arrow on top. OQ is OP plus PQ. OP is 2B and PQ is A. So OQ is 2B plus A. Or A plus 2B if you want to write it that way. Next is find QS in terms of A and B. So I need to go from Q to S. I'll go QP first. You must have the figure in front of you to help you understand better. So for QS, I'll go QP, PO, and then OS. So for QS, I'll go QP plus PO plus OS. Okay, so the value of QS is what we need to find, or the vector QS is what we are looking for. QP is negative A, PO is negative 2B, OS is positive 3A, negative A plus negative 2B plus 3A. So through this, if we simplify, QS will be 3A minus A is 2A minus 2B. This is my QS. Now, the question has given us some information in part C, and they are telling us that QX is mu times QS. QX is mu times QS. And now I need to find OX. Not to worry about this. What can I find? I can find QX. I know that Qx is mu times Qs. So now, if I know that Qx is mu times Qs was already known, which is 2a minus 2b. I'll be using that. So for Qx, just writing it in another way, I can write it as 2 mu a minus 2 mu b. That is Qx. And now I need to find Ox. For that, I can simply say that Ox is OQ plus Qx is Ox. So in order to find Ox, I do know OQ as well. Where is OQ? Might look a bit lengthy, but trust me, this is just to help you understand. OQ is 2b plus a, and QX is this. So all I need to do for OX, I'll just write the a parts separately. I get 2 mu plus 1 a and 2 minus 2 mu b. I know the b part of the vector and the a part of the vector, and they are not related to each other. They will never be like terms. So this is my OX in terms of mu a and b. Now I need to find OX is lambda OR. I need to find it in terms of lambda a and b. So the first thing that I know is that OX is lambda OR. I do not even know OR, but let's see, can I find OR easily through the figure? OR. OR is basically OS plus SR. OS plus SR is OR, so which is 3A plus B. So in place of OR, I'll just write 3A plus B. So OX is 3 lambda A plus lambda B. So this is what OX is. Now, the last part, E part of this question, where we need to find the values of lambda and mu. Okay, we'll be using the previous parts for this one. We already know that this is also OX. I'll be highlighting it to help you understand. And this is also OX. And their A and B components will obviously be equal to each other. So if I just compare the A component, I'll say that 3 lambda must be equal to 2 mu plus 1. If I compare the B component, I'll say that lambda must be equal to 2 minus 2 mu. So once I have these two equations, I can simply solve them simultaneously. I already know lambda is 2 minus 2 mu. I can plug it in the first equation. 2 minus 2 mu is 2 mu plus 1. 6 minus 6 mu is 2 mu plus 1. 6 minus 1 is 2 mu plus 6 mu. So 5 is 8 mu and mu is 5 upon 8. So once I get my mu, I can find my lambda very easily. 2 minus 2, 5 upon 8. So lambda is 2 minus 5 upon 4. I'll take the LCM. 2 fours are 8 minus 5. So lambda is 3 upon 4. That is how we can get the values of lambda and mu. Okay, so circle C1 has equation. Question 12 is what I am focusing on. X square plus y square minus 2x plus 6y 0. Those of you who are confused about equations of circle, there's a very short video on my channel. You can go through that and let me know if you still have trouble. Okay, so find the equation of the tangent to the circle at A. Very quickly, can you figure out the center coordinates of center? Quick trick is you take the coefficient of x and you divide it by -2. Take the coefficient of y and you divide it by -2. If the circle equation is in the expanded form, -2 upon -2 is 1, and 6 upon -2 is -3. So the coordinates of the center is what I know. Okay, now from the center to point A, which is 2, 0, can I find the gradient of the radius? Which radius from the center to A? So if I take y2 minus y1 minus 3 minus 0 upon x2 minus x1 1 minus 2. So minus 3 upon minus 1, which is 3. So the gradient of radius is 3. I know that the tangent is perpendicular to the radius. So gradient of tangent will be -1 upon 3. I have figured out the gradient of the tangent at A. If it's confusing, I'll just draw the shape to help you understand that if this is 1 or -3 is the center, and x का coordinate 2 है इससे आगे है और y 0 है इससे ऊपर है. So this is a point A, and we need to find the equation of the tangent at A. So what have we done? We have first figured out the gradient of the radius, which is a line from the center to the circumference, and we have said that the tangent is perpendicular to the radius. And now I already know the coordinate, which is 2, 0. Y minus y1 is equals to m bracket x minus x1. Y is equals to -1 over 3x plus 2 upon 3. And this is how I can find the equation of the tangent. Now moving on with the second part of this question. The circle C1 is reflected in the tangent at A to form circle C2. Find the equation of C2. Now, if I want to reflect this circle in this tangent, the radius obviously will not change. The only thing that will be changing is the center. So if I draw another circle and I reflected on the tangent, then what will that mean? That this is where that other circle will be. So if I actually wanted to find the center, I can say that A will basically be the midpoint of both the centers. I do not know the other center. So A will basically be the midpoint of both the centers. So center 2 is x comma y. I do not know. A is the midpoint, which is 2 0. So using the midpoint, I can say that 2 0 will be equal to x plus what are the coordinates of the center of the first circle? 1 and -3. So x plus 1 upon 2, y plus -3 upon 2. So using the midpoint formula, now I can say 2 will be equal to x plus 1 upon 2. 0 will be equal to y minus 3 upon 2. So the x coordinate of the center will simply be 2 2s are 4, 4 minus 1, 3. And the y coordinate will be also 3. So the center is 3, 3. Now we do not know the radius of the first circle because that is what we'll be requiring for the equation of the second circle. It is just a reflection of the first one. So the radius will technically not change. So how do we find the radius or r square from the expanded equation? We take the coordinates of the center, which is 1 squared. Okay, r squared is what we are trying to find. 1 squared plus negative 3 squared minus the constant, and there is no constant, so that will just be 0. R squared is 1 plus 9. So R square is 10. You can use my equation of circle video to understand all these tricks, last minute tricks. They will help you solve your questions in the exam. So I know the value of R square now. My center coordinates are 3 comma 3. So X minus 3 whole squared plus Y minus 3 whole squared is equals to 10. And this is the equation of the second circle that we will end up with. I hope this is clear. Moving on to the last question of the entire paper. Question 13 says that it is given that 2 plus cos theta is x. I can simply say that cos theta will be x minus 2 then. And 2 cosec theta is y. So I can say cosec theta will be y upon 2. Converting them into the very basic equations, cosec is 1 upon sine. So 1 upon sine theta will be y upon 2. And sine theta will be 2 upon y. They've already told us the ranges of x and y to make sure that the equations are valid. Okay, if I draw a right angle triangle, they said that, so if I draw a right angle triangle, so, and if I write an angle theta, cos theta is basically opposite upon hypotenuse. So I can just say it is x minus 2 upon hypotenuse, which is 1. Now with the same theta, if I draw another right angle triangle with the same theta, why have I drawn another triangle? Because the value of sine and the ratio is not the same. So sine theta is, my bad, cos theta is adjacent over hypotenuse. So this is adjacent and hypotenuse is 1. Now for sine theta is 2 upon y. So they are telling us that if the opposite is 2, the hypotenuse is y. Now you see we have two similar triangles, or we can just simply use sine square theta plus cos square theta is equals to 1 as well. Or we can find the other side using Pythagoras theorem. In both ways, we'll be getting our answers right. So using the algebraic one in this one in the class, I explained the right angle triangle method as well. Sine square theta plus cos square theta is 1. So sine is 2 upon y squared plus cos theta is x minus 2 squared, and the answer is equal to 1. I need to write y in terms of x, so I'll be writing 2 upon y square is 1 minus x minus 2 ka squared. Okay, I'll just expand it, then x squared minus 4x plus 4 and 4 upon y squared is, I'll just let it be this way, 2 upon y squared is 1 minus x squared minus plus 4x minus 4. So 2 upon y, I'll take square root on the entire side. I'll get 4x minus x squared minus 3. Now I can reciprocate both sides. Y upon 2 is 1 upon square root of 4x minus x squared minus 3. and y is basically 2 upon square root of 4x minus x squared minus 3. And that is how you can write y in terms of x. So I hope this must be clear now. Best of luck for your exam. If you have queries with any particular topic or any particular questions, feel free to let me know. Do not forget to like, subscribe, and share. Thank you so much. Allah Hafiz.